Okay, let's continue. So we stop at question 5. So now we have to do 6. Customers purchase a particular make of an automobile with a variety of options. The probability mass function of the number of options selected is here. So they give you the probability mass function, and they're asking you for the probability that a customer will choose fewer than 9 options, right? So the probability of the customer choose fewer than 9 options. Just keep in mind that this is a PMF. And PMF stands for probability mass function. And this is a discrete distribution, right? Okay. Okay, so they're asking you for the probability that is less than 9, right? So the probability of X equals 8 plus the probability of X. Actually, this is F of that because that's how they label this function, right? F X equals to, here's supposed to be 7, and then here 8, and you put the probability, which is 0.04 plus 0.13, so that's going to be 0.17, right? Then that's A. Then B, they're asking you what is the probability that a customer will choose more than 11 options. So that's 12 and 13, right? 12 plus 13. So that's 0.05 plus 0.05, that's 0.10. C, what is the probability that a customer will choose between 8 and 12, right? Inclusively. So 8 including and 12 is also included. So that means X, right? Actually I should put here F, right? F, that's how they label this. So F, X equals to A plus F, X equals to 9 plus F, X equals to 10 plus F, X equals to 11 plus F, X equals to 12. Yeah, so just compute these values, right? Okay, so 8 is 0.13, this is 0.19, this is 0.24, this is 0.30, 0.3, right? And this is 0.05. Okay, so just need to add the numbers. So this is 54, 59, 68, 78, 81, I guess. So what it is? You can add it, right? You can add it. So 0.13 plus 0.19 plus 0.24 plus 0.3 plus 0.05. Yeah, it's actually 91. Okay. Yeah. And of course you could just subtract 1 from these numbers, right? And then that's 0.9. So that means that 1 minus that will give you the probability. Okay, anyway. What is the expected number of options chosen? So the expectation, you know, for the PMF or the discrete distribution is the sum I goes to 1 till n xi f xi, right? So that's the expectation. So basically you need to multiply the probability times it, I'm sorry, the element times its probability of occurrence, right? So x times f of x1, x times x1 times f of x1, x2 times x of x2, and so on and so on. You're not gonna do that by hand. It will take you a long time. So you use a calculator, right? Let me show you how to do that really quick. Give me 1 second. What is that? Yeah. Okay. Good. And let me share this with you. Okay. So basically, you plug the values here. You go to stats, edit, and then you clear this up first. Clear. And then you clear here, and you put your values, right? So x is 7, 8, 9, 10, 11, 12, 13. Yes, and then you put its probability of occurrence. So it's 0.04, And then the next one is 0.13, 0.19, 0.24, 0.3, 0.05, and 0.05. Now you go to stats, you go to calculation, this one, and usually this one, the frequency is gonna be clear. So you're gonna press second, L2, enter, enter, and then you get the expectation for this one is 9.98. And they're asking in this question also for the variance and the standard deviation. So you have the standard deviation right here. Standard deviation is 1.42. So 11, and then you can square that and you get the variance, right? So 1.4211 square, that's the variance. So that's the variance is 2.01 or 95, right? Or 0.02 if you want, okay? That's it. Let me go back to the slide. Okay, so now we are back to the slide. So we did already this question, right? So we calculate part A, part B, part C, and D is just the expectation, okay? So I show you that how to do that with a calculator. Okay, next. Okay, this part we're gonna need to go below, right? So let me see if I have that question here. Yeah, I have that question here. This question is a little long too. And then everything else is easier after that. Promise you it's not that difficult. Okay, so let's do that from scratch. So here they're asking you, because not all airline passengers show up for the reserved seat, an airline sells 125 tickets for a flight that holds only 120 passengers. The probability that a passenger does not show up is 0.10, and the passenger behave independently. What is the probability for part A? What is the probability that a passenger who shows up gets a seat? So in order for all of them to get a seat, at least 5 days should not show up. But let's try to understand what's happening here. So first of all, we need to identify what kind of discrete distribution we're dealing with. So here, they mentioned that the probability of the passengers' behavior is independent, right? So that means the probability if one passenger does not show up, that doesn't affect the probability of the next passenger showing up or not showing up. So those events are independent. The probability is fixed. You can see here that's 0.10. And it's a probability, we have a M Bernoulli trials, meaning we have a success and failure situation, right? So that means that the probability of success is 0.10, failure should be 0.9, and then your sample size is 125. And we need, the first question is asking for the probability that a passenger who shows up gets a seat. So at least 5 should not show up, right? So this is 1 minus the probability of x less than 5. So this is what we know that this distribution is a binomial distribution. Before I do part A, distribution is probability of x, the random variable choose little x is n choose x, p of x, q, n minus x. Okay, so this is a binomial distribution, right? I know it's binomial because the probability passengers behave independently. That means the probability of one does not affect the other the probability of one passenger not showing up does not affect the probability of the other passengers showing or not showing up. The probability is fixed, is 0.10, and it's a Bernoulli trial. It's either M Bernoulli trial is either success or failure, right? So this is a binomial distribution. Okay, and I just need to compute this, right? The probability of x is greater than 5, at least 5 need to be 5. Let me define the random, like my random variable x equals passengers not showing up, right? Or not passenger does not show up. Okay, so that's my random variable. So probability of x is greater or equal than 5, because at least 5 need not to show up for everyone to get a seat. So this is 1 minus a probability. I cannot find the probability of x is greater than 5, right? Because I have a sample of 125. So that this would imply that I have to do the probability of x equals 5, probability of x equals 6, 7, 8, 9. That will take me forever. So I'm going to do just a complement. So this is 1 minus the probability of x is less than 5. So that implies that this is 1 minus, well, this will be probability of x equals 0 plus probability of x equals 1 plus probability of x equals 2 plus probability of x equals 3, right? And you know that this is a binomial distribution, so that means I'm gonna just do for 2 of them. I'm gonna do for this and that, because that will take me a lot for me to write. So this is 125 to 0. So success is 0.10 to the 0. Failure means 0.9 to the 125. And then plus 125 choose 1, 0.10 to the 1, 0.9 to the 124, and so on and so on and so on. So you need to put this in the calculator because it takes a lot of time to do by hand. So if you go to the calculator, you will do this. You clear this up, you put second distribution, and you go to binomial PDF, click on that. 125 trials, the probability of success is 0.1, and then you start with 0, and you click on that, and that's the first probability. Then you click second, enter, and instead of putting 0, you put 1. That's a probability of 1. Then you press second, and then you change this to 2, and then you press second, and you change this to 3. And you press second, and you press this again, and you change this into 4. And you need to add all those probabilities, right? Like everything that we type here, you need to add it up, right? You need to add this one, plus this one, plus this one, plus this one, plus this one. And then you subtract that from 1. So it will be 1 minus the sum of those probabilities, whatever the number is. And you should get 0.9961 after you do that. I'm not gonna do that because that requires a lot of time, and when I do this in the computer, it takes time. Okay, so you can do that. Just remember, add these probabilities, right? Add these probabilities. This plus this plus this plus this plus this, and you subtract. You add them up, and you subtract that number from 1, and then you get your answer. And you're supposed to get 0.91, 0.99 something. It's right here. You're supposed to get 0.9961. I put this is the sum of those numbers, right? So you can see this is the sum. Okay, this is the sum. Okay, and you subtract that from 1, and you get 0.9961. For part B, so this is part A. For part B, they're asking you, what is the probability that the flight departs with empty seats? So think about it, right? If we have 5 passengers, everybody gets a seat, right? So if you, at least to get 1 empty seat, 6 not need to show up, right? Because remember, my random variable is passengers, that does not show up. So at least 6, if 6 does not show up, at least I will have an empty seat. So what is the probability of that? That's 1 minus the probability of the complement, x less than 6. So again, I have to do this long work, right? So this is 1 minus the probability of x is less than 6. So that means that the x equals to 0 plus x equals to 1 plus x equals to 2 plus x equals to 3 plus x equals to 4. And you stop at 5, right? Because 6 is not included. But you might think it's a lot of work, but it's not, because you already have until 4. So you just need to add 5, right? You just need to add 5, and then so whatever number you get from this previous step, you add the probability of x equals 5, and you subtract that from 1. So that will be 1, right, minus whatever number you get, right? And that should be give you equal to, your answer should be, after you calculate that, you should get 0.989. 0.989. Again, if you forgot how to do the probability, you do like this, okay? So you do this way. You clear this up and you put second, bars, PDF, binomial PDF. You already have that. If you want to find the probability when x equals 5, you put 5, press enter, and you add it up to the other probabilities, and then you subtract that from 1, right? That's what you have to do. Okay, so let's go back to the slide. Okay, so that's how you do that problem. And the last part is asking what are the mean and the standard deviation of the number of passengers who show up. So I'm gonna make this smaller. So I can put part C here. So part C is asking you for the expected, the mean and the standard deviation. The mean of the binomial distribution is just NP, but you have to be careful here because you see I labeled my random variable, you see the passengers that does not show up, right? So here they asking the what is the mean of the number of passengers who show up. So that means the probability of success for that specific question will be what? 0.9. So that means this is 125 times 0.9. So that would be my my expectation. 125 times 0.9, that would be 112.5. And my variance, I need to calculate first, right? So this is MPQ. So this is well, is 125 times 0.9 times 0.1, and that's equal to some number 0.1, 11.25. But we're looking for the standard deviation. So you take the square root of that, and the standard deviation is 3 point something, I guess, 3.35. Okay, so that's the answer for that problem. So that part is not that difficult. So this is that, right? So this is the expectation, the mean and the standard deviation of the passengers who show up. Okay, so that's done. So let's next question is what? 7, 8, right? So this question is not difficult at all. Okay, I made a typo. I already fixed these probabilities. Actually, I didn't fix those probabilities, so let me fix it really quick. Let me fix it really quick. 1 second. Okay. It's supposed to be 0.1, 0.1. So this is also 0.1. Then 0.3, 0.2. This is also 0.2, and 0.1. Okay, that's it. That's the only thing I need to fix. Okay, you can fix that in your sheet too if you are working these problems. Okay, so we almost finished this thing. Okay, we almost finished. So they're asking you verify the validity of the PMF. So basically the probability has to be equal to 1, right? That's just the axioms of probability. So this is the probability of x sub I is supposed to be equal to 1. Yes? So you just need to add the probabilities and check that they're equal to 1. So 0.1 plus 0.1 plus 0.3 plus 0.2 plus 0.2 plus 0.1. Is that equal to 1? Check. 2, 5, 7, 9. Yeah, 1. So true, right? Next. What is the probability of the random variable be less than 2.5? So 2.5 are all these numbers, right? All these numbers are less than 2.5. So that means The probability is equal to 1 again. What is find the probability that the random variable is between 0.15 and 4.5. The only thing I need to do is just don't add this probability, right? Because that's less than 0.15, right? That's less than 0.15. So that implies that I just need to add everything else, right? So the probability of x 0.15, x 4.5, that should be 0.9, right? Should be just 0.9 because we're not adding the first probability. Okay, and what is the expectation? Again, you can just put in the calculator, right? These values and get your answer. So the expectation of a PMF, or the probability mass function, is the summation I goes to 1 till n, x sub I, f x sub I. Okay, so calculator, right? Calculator. What is that? Calculator, and here, calculator, what is that? This thing. Okay, so stats, enter, clear, and you clear this again. We need to put 0.1 this time. 0.1, and then 0.2, 0.3, 0.4, 0.5, 0.6, and then the other numbers are 0.1, 0.1, 0.3, 0.2, 0.2, 0.1. Yeah, and then you do stats here, this one, make sure that this is going to be clear. If it's already L2, then that's fine. You put L2 calculation. So the expectation is 0.36. Okay, so the expectation is 0.36. 1 second. Just to check. Yeah, that's the expectation, 0.36. So let me go back to the slide. So the expectation is 0.36. Okay, so we're done with that question. Next question: decide whether a discrete or continuous random variable is the best model for each of the following variables. So this is straightforward. This is just basically stated what it is: the lifetime of a biomedical device after implanting a patient. So that must be continuous, right? Its lifetime is not exactly like 5, 4, 3. It can be, I don't know, 5.5, 2, 3 years or something like that. I don't know, right? Something that's continuous. The number of times a transistor in a computer memory changes state in a time interval, that's discrete because they're asking the number of times a transistor. The strength, that's continuous. The strength, like you can think about Newton, right? That's a strength. Or another measurement of strength, I don't know, whatever you want. So that's also continuous. The number of convenience, convenient options selected by an automobile buyer, that's also discrete because it can be 5, 4, whatever. The proportion, that's also discrete. The weight, that's continuous. The number of molecules in a simple gas, the number of molecules, that's even though it might be infinite, but it's countable. So this is discrete. The energy generated from a recitation, that's continuous. And the concentration, yeah, this is also continuous. Okay, that's it. Now for each scenario described, all are situations involve binomial or not, right? state whether the statement is true, meaning it's binomial or false. Okay, so this is a true or false sort of thing. Let X be denoted the number of contamination particles found on 40 randomly selected. So these 40 randomly selected, they behave independently, basically. They didn't say that there's some sort of dependence here, right? And therefore, this is binomial or true. And this part, they're asking you from a batch of 50 temperature transducers, sample size 30 is selected without replacement. That means that the probability of one will get the probability of one might affect the probability of the next size or sample size, right? Or the next batch, right? So that means that this is not binomial or false. Okay, and don't forget, just in case, in the test for independence, we said that the probability of A intersection B must be equal to the probability of A times the probability of B. These are the statements for independence. Probability of A given B is the probability of A, because that means that B is not affecting A. And the probability of B given A is the probability of B. That means A is not affecting B. So this is the statements for independence. And this comes from the binomial, the conditional probability definition, right? Probability of A given B is the probability of the intersection times over the probability of B. If you cross multiply, this is the probability of A given B times the probability of B equals probability of A intersection B. Meaning, if the probability of B, this is just the, I mean, if the probability of, for independence, right? If the probability of B does not affect the probability of A, then by default, this is the case, right? So that means that that's the reason we said that the probability of A times the probability of B is the intersection. Okay, so these are the definition of independence. I hope this makes sense to you, and good luck on your exam. Thank you. Bye.